hello. Ready for day 6 of Advent of Code, and here we are. Here's my input. Here's my file. I will explain what has happened shortly, but we gotta solve this problem first. Total is this number. Things are failing. I have to actually read the problem. Each problem's numbers are arranged vertically. At the bottom of the problem is a symbol, the operand that needs to be performed. Problems are separated. So it's all these times each other, all these plus each other. Okay, I can do that. So it's things up. Let me snooze that real quick. Equals data dot split. Find the new line dot map. Line dot split by number of white space. Symbols on the wrong place. Let's see what we got for things now. Okay, for each of these lines we need to do a dot trim first. Boom, that's better. Okay, so now const rows equals things. Well, actually I can just do this for let I c equals 0, c less than things dot 0 dot length c plus plus. Const row equals the array for const let r equals 0, r less than things dot length, r plus plus. That should be my rows. Row dot push things are c. Row looks like this, so that is great. What I need to now do is slice the last one off. Const up equals this. Up. Dang it, that's not how you do it. Slice from the -1, just go to the end. There we go. So now we have our operator. Then we also have our row. Dang it, didn't remove it. There we go, that's what I wanted. Row dot join up const expression. Expression is like this. Eval expression res equals this. Great. What do I do with all these numbers? Do I add them all up? Okay. Plus equal res. Total 0. Return total. There we go. I have a NaN because I haven't put any of my input in. Let's go grab that. Got that. Here's where all my code falls apart. Big number. Take big number. Shove big number into input. Be wrong. Okay, be right. Great. Now how's my efficiency wrong? Cell phone is right to left in column. Blah, 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 blah. Reading the problem right to left one column at a time, the problem's not quite different. The rightmost problem is 4, 431, 633. Where's the 4? Where's 431? Where's 623? I can't see any of these numbers. Is it... Do I reverse 326? Nope, I don't see it. Problem is still separate for column because there's only space, and symbol at the bottom, problem still operator to use. Right to left in columns. I don't. Oh, this is a problem. If I can't understand the problem, I can't solve the problem. What am I looking at here? 4 plus 4, 3, 1. Oh, 4. 4, 3, 1, 6, 2, 3. Great, it's the other way around. So solve 2 is basically just completely not solve 1 at all. Great. Get rid of these logs. Get rid of all that. I will have to rethink and target this a completely different way. I love it. Okay, take it, shove it in there. I'm expected to give this number. Okay, let's get rid of all of that. And let's walk through what I'm supposed to do here. So I have row, which is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Just where's the 1? Oh, and it's also the other way around. 1, 2, 3, 4, 5, 6. So I don't like what this ended up doing. I hate it. I hate it. Can I do math to figure this out? What's the width of every column, basically, is what I'm looking for. So the number of spaces between each is how many of those. Okay, that's one way I can do it. I can also take each number, convert it back to a string, pad it to the length of its longest one, and then start chopping through that. That's what I'm going to do. So I'm still going to do all of this, row, op, expression, but now at this point, row is good stuff. Okay, great. So cost of row equals row dot reduce b dot length greater than b dot length a b default empty string. Longest of row is great, and then I need a dot length on that. Okay, great. So const padded row equals row dot map I or s dot pad end, no, pad start, longest of row, and with an empty string, padded row. Okay, I've done that. Now all I need to do is traverse through these. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's 356. Okay. So for each of these rows, I need to so it's column for let RC equals padded row 0 dot length minus 1 RC greater than or equal to 0 RC negative negative. And we're going to break here because I don't want to go through all these other ones. Okay, we're going to return here because I don't want to go through these other ones. RC 2 3 1. Okay, which means I need to now get all the numbers in there, in there, and in there. So const or let RR equals padded row 0 dot, nope, not that one, dot length RR less than, which way am I going though? So padded row, so wait, RC means I am looking at 2 1 0. I need to look at padded row 0 1 2 2 2. So 2 of 0 0 0. Okay, so for let RR equals 0, RR less than padded row dot length RR plus plus. Now const new num equals empty string. That shouldn't be a const, should be a let. New num plus equal padded row RC. Let's see what I got here. 3 5 6 24 1. I have to go back to the example. 3 5 6 24 1. Okay, great. This is it. These are all three of them. Const nums equals boom. That's not how it works, but we'll try it. Nums dot push new num dot trim. Okay, now we have nums. Okay, great. We have the nums. Now we have to just use all that for there. Expression is not row join op, it's nums join op. And that number is wrong. It is slightly off. I need to see what nums got generated. Okay, we got 4 of them. 3 5 6 24 1. 3 5 6 24 1. Now let's look at the expression. 8 4 8 2 6 9 3. Dang it, where'd that come from? 8 4 8 2 6 9 3. Yeah, that did not end up doing correctly. Padded row 3 2 8 6 4 9 8 6 4 9 8. Oh, look at that padding just jumping around freaking randomly here. Oh. Dang it, my entire algorithm don't work like that no more. I need to keep them as is. Okay, that's doable. It's still doable. The problem is that I clean and trim and I move all this. So I need to look at things and not do all this stuff to here. So 1 2 3 4. So I have all the lines. I need to split them by the last one. So data.split, new line at -1. Boom, that's the last one. Now this is what I need to split up accordingly. I have to count the spaces though, unfortunately. We'll have to call widths equals 0, empty array, so for let I 0, I less than ops is right here. Ops dot length. You know you're real, you're not undefined. I plus plus. Let your width equals 0. And then I'm just gonna build this up. So if I equals empty space, not I, but rather ops I. Then I'm going to say cur width increase, else call widths push, cur width, and we're also going to reset the current width. Now there's going to be a lot off by ones here, but that's okay. I will now see column widths, which is 0, 3, 3, 3, 0, 1, 2, 3, space, 1, 2, 3, space, 1, 2, 3. Okay, so the first one is wrong. Wait, there are 4 of them? Yeah, there are 4 of them. Now, why is the first one wrong? How do I get the first one to be right? I mean, I'm counting the number of 1, 2. So it's the number of spaces between. So it's technically this plus 1, but then it's all minus 1. Ooh, do I have a cur width on here? I do. There we go. If cur width, call width dot push, cur width plus 1. There we go. So I think and then we slice off all that. Look at my input. Is it okay? It is like that. Great. Splice 0, 1. There we go. Get rid of the first. Now all of you say 3. I'm gonna have to have you stop moving. I can look at what. Please stop moving. So yeah, we got 3, 3, 2, 2, 2, 3. Oh my gosh, go to the front. 3, 3, 2, 2, 2, 3. So that is correct. The way I got there is terrible, but it's correct. So now I need to actually do stuff with this. So now I need to rebuild things, but like this. So const new things equals congratulations an array for let the line of data split new line const calls equals this for let width of call widths. This is gonna be interesting. I'll have the line here so I can just mutate it. So const cars equals line. Just going this into an array. Am I just like, hey line, splice from 0 to width? But I'm gonna push all this to calls. Why is splice not working? You're a thing. Oh, there you go. Then let's break here so we can actually see what we got. Columns 1, 2, 3, blank, blah, blah, blah. That is terrible. What is my call widths? 0. What am I looking at? Oh, yeah, okay, we need to put you back together. There you go. So 1, 2, 3, space. What am I looking at? 1, 2, 3, 32. Oh, that's right. Every time you do this, you need to go, what is it? Plus 1? Oh, well, once you do this, you need to get rid of 1. There we go, like that. 1, 2, 3, 38, 51, 64. And that's with the correct spacing. Okay, this is good, this is good, this is good. So now I can just push this into new things. Push calls. Okay, now look at new things. Is this everything we want it to be? It looks good. Okay, great. Congratulations. We don't use things. We use new things. Friendship with things is gone. Friendship with new things is here. Now we got a lot of space around it. So congratulations, you don't pad anymore. Congratulations, you're not a padded row. You're just the row. I'm assuming a lot of this is going to be okay. Oh, it is. Grab number. Big number. Be the friendly number. Boom! Whoo! Boy! Okay. Now I get to breathe. Okay, first of all, sorry for the rough solving. I'm gonna go check OBS real quick. Yeah, OBS seems to be running. Yeah, sorry for the rough solving and the last minute ness as it felt of this. I was on the road and did not get home at the time I thought I would, so I'm just doing this on my work laptop. As it's probably obvious from Macintosh and no stream and OBS and all that stuff being whack. But we got through it, so I can breathe now. So, let's start by git add 2025. Fortunately, I can't actually commit it because I'm not logged into my correct GitHub, but I will later. Let's understand what they are asking us. So, we got some numbers in columns and rows. They gave us a spreadsheet. A space-delimited spreadsheet with spaces in here that meant stuff. Very torturous. But there are problems and there are operators. For the first one, they just asked us to take these numbers vertically and apply them to each other with whatever operator is at the very bottom here. So, for the first column of numbers, I'm going to go to TLDraw to explain this. Oh my god, it's light mode. That's because I'm in an incognito window. I'm so sorry. I'm so sorry. Okay, wow, that hurts. I'm back. Okay, let's get rid of this. Why? Please be paired. Why does TLDraw not want to give me my new lines? Okay, I'm just going to paste it here and then copy it back into my clipboard. Great, okay. I don't understand things. But this is working. Let me fix this alignment. Where'd the rest of my symbols go? Oh, they turned it into Markdown. Oh my gosh. Oh no, stop. Rich text formatting. No, stop rich text formatting. Okay, good. Oh my gosh. Oh my gosh. Okay, I give up. How do I paste plainly? I'm pushing all kinds of Shift Command V's right now. None of them are working. It's okay. You know what? When it attacks us with lemons, we do something with lemonade. So star plus star. Oh well, this isn't much better. But there are rows and they have operators at the bottom. We're supposed to take them and execute them like this. So each of these are a different problem, and we execute them accordingly. Which means for the first one they give us 123 times 45 times 6. And once we have the results of all these executed expressions, just add them together. So that's the first one. That's what they want us to do. For the second one, what they want us to do is a little different. Here, they're saying a lot more things are vertical. So it took me a while to see this. But for this first example, it's actually the rightmost example. So it's kind of hard to read. 4 plus 431 plus 623. 4 plus 431 plus 623. Seems simple and straightforward. But one thing that's not obvious is that these are not left aligned or right aligned columns. By that I mean, looking at this column here, this one right here, we would say all of these numbers are right aligned, which means like the beginning of the number starts to the right of the column. That's not the case for the second column. These are all left aligned, which means my original implementation of just ripping out all the white space and rebuilding it accordingly did not work. Now, this one is right aligned and this one is left aligned. Okay, I'm now seeing a pattern. Are they alternating alignments? No, left, left, unknown, left, unknown, left, unknown, 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 left, 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 well, unknown, left. Are they all? And then boom, here's one that's right aligned. Now the reason this matters is because the rebuilding or the reconstructing of these numbers depends on the vertical alignment. For the second one here, it's 175, 581, and 32. 175, 581, 32. That completely changes if 51 is left aligned. It's now 75, 181, and 532. Completely different numbers. So it's important to not change the alignment in the slightest. Which gets on to how we actually solved it. So let's step through it line by line. Starting with 1. So this was before I realized the importance of those alignments, but just looking at it like so. What we first did was we took all the data and we split it into lines. So that looks like this. Just every single line, different string. Straightforward. Then what I did was I got rid of all the white space by splitting on it. Now the trick is I'm using a little bit of regex here. I'm saying any white space character followed by, I don't remember the regex actual term for this, but this collects as many as possible. Now if we look at this, I'm going to show it a different version where I would just, let's say, not use regex. And let's just do it what a normal person would do. Split by space. Well, whenever there are two spaces, you get these things showing up. Absolutely terrible. Now technically we can get rid of them by getting rid of anything that's falsy. Oh my gosh, that's not what I want. And you end up with the same things on the other side. Well, I guess I kind of just blew out the advantage of necessarily having to learn regex and use regex for all this. But this is a string manipulation problem, so when you're dealing with that, it's slightly better to use regex. It's kind of built for it. But once you have all of those, now we need to go through all of the columns. So that is C. So each column, so this is a column, this is a column, this is a column, this is a column. So we're going through, in this case, 4 columns. We can see 0, 1, 2, 3. Then we need to rebuild what the numbers would be. So I called it a row here. I don't really like this. This is technically the column. Yeah, it's weird. Row and column when they are one way and then we're transforming them another. But we're building the column and then we're going through every row of I really hate the word things here. Lines, it's good enough. What we're doing is we're pulling out each of those values and then we're rebuilding the column the other way. So 1, 2, 3, 45, 6, asterisk, 1, 2, 3, 45, 6, asterisk. So instead of doing a normal traversal, which is row by column, where you go 123, 328, 51, 64, then 45, and all this way, it's the other way. It's column, and then on to the next. It's column by row instead of row by column. So once we have that, we now want to get the operator, and we both get and remove the operator using the splice method. So I'm going to show where you have column before and column after, or a return here, where you can see before 123, 45, 6 asterisk, but then we splice. Notice this is splice, not slice. The P, it means it removes also. And we say remove starting from the last one. And then we just extract the 0th because splice returns an array. So this doubles as us removing the last thing and getting it, storing it in the opera variable. We love that so much, we then turn that into the expression, which is just this right here. Oh, so I could make it cleaner. There you go. It's slightly more readable. And then we get lazy. Good old eval. Don't trust this with your input. It's just running arbitrary code, but instead of actually, let's say, looking at the operator and handling additions myself, I just said, hey, JavaScript, take this expression, go evaluate it for me. And that gives me the result, which is the actual number. I add that number to the total. Bob's your uncle. We're done. Boy, this second one was a bit gnarlier. I'm actually going to take a quick break. Okay, back from a little break. Now to walk through how this part 2 code actually works. So, what we do is for the input, all we do is we just go through it and we figure out the widths of every column. Because originally, where I was just stripping all the white space and putting it all back together and repadding it, that doesn't work due to the left and right alignment that is unpredictable. So, first we need to get the width of every column. And you see that one's 4 wide, that one's 4 wide, this one's only 3 wide. And then technically, the column itself is only 2 wide, not 3 wide, because there is a space delimiter between all. So, that work needs to happen. We create an array that is supposed to contain the widths of all the column. We go through this. If the current character is a space, increase the width of the current column until you hit a non-space, at which point, boom, you've reached a column boundary. Add it, reset it to 0. This handles the fact that the last column, you're not going to reach a non-space, so you got to manually put that one in there. And this gets rid of the first one, which is a moot column width, allowing us to come up with this. And we got to turn off the real one. Allowing us to come up with this. And for the input that we have, each of the columns are 3 wide, but the code works. The code works. So once we do that, we need to effectively generate things. Let me snooze that. We do need to generate the same data structure that we had before, but we need them to be with the white space. So it goes through every line, gets all the characters, puts it into an array. That's on purpose, so that way we can basically keep chopping off however many we need from the front of that array with our good old splice here. So we can see that characters starts off as this, and we're going to go ahead and put a return here for easily visualization. So 123 space 328 space 51 space 64 space. Ignore that last one. Well, don't ignore it, it's important, but you can see all the characters here, and then after we chop off what we need, it turns into 328, 5164, 5164, 64, and then nothing. Notice how after we chop off 328, 51 still has the space in front of it, which is important. Those spaces are the magic sauce we need. So that does that, building up the columns, which has the spaces on the numbers as they were originally. The rest goes, I won't say exactly the same, but mostly the same. We're rebuilding the equivalent row of, great, here are all your values, weird spaces included. Get the operator just like last time. That variable's not needed, I guess. And then yeah, this is building the row, or rebuilding the numbers, but in the, of course, come back, in the other axis, in this vertical axis. So we already know we have row, which I'm going to put a return there so we can just look at the 1. 1, 2, 3, 4, 5, 6. So for this one, okay, I'm not actually logged in anymore, but we know what this is. This is meant to be put together 1, 2, 3. So it's 3, 5, 6, 24, and then 1. Or it's the other way around. Tomato, tomato, but those are the numbers we're aiming for. So we go through the row columns. Now this is a reverse for loop because we need to go from the bottom up. Then we go through the rows, which is normal. So demonstrate this 2, 1, 0. And for all of these, it is row RR. Let's see. So we can see 3, 5, 6, 2, 4, 1. Just as we want. Building up new num. So 3, 5, 6, 2, 4, and the 1. Of course, we then push this to our numbers, and we do the exact same thing we did before. Join them all up together, our expression, evaluate our expression, and result in our total. So that bottom half, that back half, identical to what it was before. The middle of the front half, same as we did otherwise. It's just the parsing of the numbers that was the real challenge. As for a refactor, I don't think, unlike the previous refactors, I don't think a single function is actually going to be able to magically solve this. Or at least not a simple, straightforward function. I'll make it into a single function, but it's going to be one that takes in different inputs, maybe even a callback or two. Before we jump into that, though, let's factor them as is. Give these some good names. Reduce extra variable usage. Go in column. Is column a good name for this? Let me get rid of the real runs for both of these as I refactor accordingly. It is technically the column. Yep, so that wins. Yeah, I think that is sufficient. Ooh, is there a mapping opportunity here? Unfortunately, actually, there might be a mapping opportunity. Let's see if we can do this. Const column equals lines dot map. So this will be row, and then will be row column. Okay, let's see if that worked. 985. Let me make sure if that's it. Yep, that is. I really need to. Let me copy that. Time travel real quick. I don't remember what the actual number is. 985. Yes, it is. Awesome. I'm gonna save that with a comment real quick. There we go. Much cleaner. Still need multiple expressions. Good, good, good. Okay. I think this is as clean as that one gets in isolation. Oh boy, this thing though. Yeah. So let me figure out the boundary points. So this can completely replace the other one. So this whole new things, if I just take all of it, it completely works for the previous one. So instead of lines, well, lines is actually a good name for it. So let's just rename you to lines. Boom, everything works as expected. Perfect drop-in. So this is what we're going to be doing. Got to make it a bit cleaner though. Maybe even down to a helper function. Parse. What do y'all call these? Problems. That's what they call them. That's what I'll call them. Great. It's all this and this. Chop, chop. And then, there we go. What do we do with our ugly code? We shove it in a function and then collapse it to never look at. No. We'll make this good. Operators. Oh. There we go. Rename this. No, close. There we go. You're not being updated, so that'll work. Operators. If you're going through the length and you're just doing it once, congratulations, you just turned into a for of loop. There we go. Forgot my exclamation point. Perfect. That is good. Make this slightly more readable. We'll figure that how to fix it later. Get rid of the moot point one. Okay, so it's really two halves. It's figuring out the widths and then it's building the lines. Let's see which one I want to make cleaner first. This could be a double reduce, or it'll be a reduce of two variables. It's a little gross though. Plus you have to handle this leftover and this splice. So it's another helper function. Dude. Bop, bop, ba-da, bop, bop. There we go. Still passing the entire data along. I suppose it doesn't need the entire data, it just needs the operators line. There we go. I like that one a little better. There we go. You have exactly what you need. You calculate your width, you do all your very hard work, and then give me my baked cake. Okay, I'm liking it. Type's probably failed. No, I figured it out. That's a good TypeScript. Let's see if I want to make this any better. Actually, we're slicing operator is 1. I think that allows us to get rid of this weird bit, right? Yeah, awesome. Got rid of that weirdness. How do we handle, how can we get rid of this leftover? Because there's always a leftover current width, because the loop goes more than it can. Ooh, here's a trick. We can add a random thing at the end. That'll force it to reset. Hey. Ooh, but now it hates it. Because it needs to be +1. Do we add a space in the thing to reset it? There we go. I love just manipulating the data as we need it. Actually makes it much cleaner. Or at least there's less side effects, which I like. We still have this. So we have the column widths that is as is, the current width that goes up. I suppose this is fine. Yeah, I'm not seeing a cleaner way of doing this. I mean, this is slightly cleaner, but I suppose this suffices. Awesome, so now we have this to deal with. Okay, we're doing this. That can be a const. Let's see what we're doing here. We have the characters, and then we're chopping off those fronts. Okay, we're very much mutating of this. Another const here. Okay, so this is a mapping over column widths. So there's a mathematical way of just pulling out the correct nth characters instead of doing this. So I would like to refactor it to actually do that.
Because what we keep doing is splicing from the front of this array. That is the most expensive operation you could do because it has to move everything to the left. So very expensive. Don't like doing this. Let's think of a better way of doing it. And we're going to see what you come up with. Column width 3 through 3, and then you come out with lines like this. Parse problems. No, not data. The fake one. There we go. What do you get out? You get out this thing, huh? Okay. Well, I'm sure I can get a assertion on you. Boom. Doing a little test-driven development because I'm probably going to mess this function up a bunch of times as I write it. But now I won't need to worry because I got my old friend there. If I make a mistake like that, it lets me know. Okay, out with the old, in with the new. Let's do this. Now columns should be, like I said, mappable over column widths. Map. That's not what I wanted. Widths.map, so we have each width. Now the fun part is that it needs to also be offset by all the previous ones too. So map might not be the easiest first one to go with. Let width so far equals 0. There we go. So what we want to do is we want to. I'm going to need this variable back. Basically everything I commented out, very important. So we're going to push slicing of a line from start, which is width so far, to width so far plus width. And then after this, it'll have to be width so far plus equal width. Did I do it? I didn't do it. Okay. Are we off by 1? Nope. Okay. We're not doing it at all. What do we got? 1, 2, 3, 12. Okay, these all look good. What's wrong with us? Ew, hey, what's that? Very ew. Oh, I can also see everyone's getting offset by 1 in some direction. Okay, so plus 1. Maybe we need to do this plus 1. Oh, there we go. Things are lining up. That's why we got test. Inclusive, exclusive, off by 1 errors is the explanation for what we needed to do there. So that is better, no longer mutating that giant thing. I do think I can hit this with a map, or at minimum with a reduce. I'm going to go with a fancy reduce. Equals column width, reduce, and then I have previous, current. Now, hold on, let me think what I want here. I want to destructure columns width so far. There we go. And then we have, what is this? The next width. We love it. I'm going to do some stuff here. I'm going to initialize this with columns, empty array, width so far 0. And the trick is that we say dot columns at the end of this. That's all we care about. Now here we have to return the same data structure. So in columns, and then width so far, the number 0, I guess. Now this is all angry because just TypeScript, but functionally that's the same data structure. Now we get to do the fun part. What is in columns? Well, it's this. It is all the other columns and this new one. And what's width so far? It's width plus 1. Now, it's angry for reasons. Why? Columns. So I know Oh my gosh, I did not want to go in there. Do I spell columns incorrectly? Returning the object. I have the width. What have I done here? Does not exist on number. Well, yeah, you're not returning a number. You're returning an object. What's wrong with you? I've done something bad with parentheses. What is wrong with you? You're an array of numbers. Your number should be reducing over this cool object. Why are you saying you're returning numbers? You're returning an object. Yeah, this is the initial value. Does not exist on number. Well, no, I gave you a string now, so that's supposed to be your initial value. Collect function, initial value. What have I done wrong? This is why reduce is terrifying. Type number. Who said you were a number? Oh, if I swap these around, is that the problem? No, TypeScript says that this is the accumulator. That's what I thought. Return object where columns is this. Oh, it's not a number. And well, you're not supposed to be a number. You're supposed to be a string. Was it me? Oh my gosh. The problem was me, folks. Okay, now why is it angry? Oh, it's supposed to be the current width. There, +1. There you go, like that. Okay, everyone's happy. I was the problem. I was like, why is it a number, guys? Why is it a number? Why is it a number? It happens. Well, now I can simplify this to the cleaner one-line version. Now that nonsense is over with. Do I need to type this at all? Okay, you don't know what's going on. Gotcha. Okay, so then that is equivalent to that. Readability took a hit, unfortunately, but I like it. And I've kind of sunk cost fallacied myself into it because I've already typed it. Awesome. Okay, and then this is going to make it the least readable thing in the world. Boom, get straight into there. Yeah, nobody needed to read this at all. Ooh, you know what this is? Yeah, we're going to make it less readable. There we go. There we go. You know what? Yeah, we didn't need to read any of this at all. Okay, well now it's more readable. Darn formatter. Yeah, actually does make it readable again. But there you go. That's a little bit of over refactoring, very cursed. And now we collapse it like it was never there. Awesome. So that is working, and this is still working, and I'm going to say goodbye to that. You have served your purpose. Now, the trick is solve 1 and solve 2. They use those slightly different. So what happens differently in solve 2 is literally this bit here. So this is, what do we say this is doing? Excuse me. So it's building this column variable, right? That's the work. That's the work. Okay, so we're going to pass it a function that says generate okay. I've come up with I've not come up with a great name. Do the thing. You are a function that takes number, well, this is column number, and you also take, what is it, lines. You need both, don't you? Yeah. And then you return an array of strings. That is what it needs, right? Because when we do this, we do, nope, down here. There we go, numbers. We need all the lines, we need the rows. We'll find out. Let's just make this work. So, there we go. We're going to pass you C, and then we're going to pass you all the lines. And then part 1's going to do this. There's your second thing. Well, C lines. Boom. Like nothing's ever changed. Oh my gosh, what formatting. What accursed formatting. That's okay. Functionally identical. Now this is where solve 2 is gonna really make or break it. Because theoretically, I should have to take this logic and shove it into the callback function and everything works. So let's swap solve 2 with solve 1 data. And this right here all the way up to nums. So we have C, we have new things, just because that's what's called in this code. Great, unexpected number. Wow. Okay. So let's not do this anymore. That was a really good chat. We're gonna say goodbye. And we're going to understand what nums was. Ooh, so it's nums, it does not have the operator on it. Okay, it's a slight difference in how this is handled. Is row the same? Yes, row is the same. So that base code is the same. What if I give more responsibility to the callback to return both the numbers and the operator? I'd say let's go for that. Let's go for that, because this generation is important to be like that. Okay, you get more responsibilities. You return... You know what? No, I'm done. You are doing that. What you're just going to do, you're just going to do it at the end. So while this has to remove the operator for its math, watch what it's going to do. Put it back. Hey, and it's working. And that is correct. Okay, we have dried out a lot of this. Now we have to make some things good, because this is solve, not solve 1. There we go. And then you call yourself with data, and then this. Swap that name down. There we go, everything's starting to look good. There we go. Please format better. I will fix you later. Okay, and now you return the main solve. Okay, all that remains is cleaning up this mess here. So I think this is identical to what I had, or what I had optimized it to here. Row equals drop all those. Boom, identical as expected. You remove the operator, you do a bunch of stuff, you put the operator back. Let's see what we can do about that. What if we didn't remove the operator? Someone's gonna go for too many. So I do just -2u, and because you don't need the operator. But you do need the thing at the end of row. There we go, like that. Boom. So I -2u. Do I need to -1u prevent you from going back? Oh, there we go. So I need to put the offset on the other number. That is working beautifully. Okay, row, none. Let's put the operator back. Looking good. Why do we even need to take you off to begin with? You're not doing any number parsing, you're just getting the characters on that thing. So I say you get it. Yeah, look at the O. Hey, why'd you do that? Okay, so when I do that, it doesn't exactly... It's not that important, honestly. It's as good as is. Let's see, rename this to column, rename this to lines, rename this to numbers. Rename this, not make a new window. Rename this to new number. It's not a new number, it's the thing we're building. Oh, words are hard after all. Don't even know if we need this RC and stuff. We just say C and R. There we go. Looking at it, are they C and R? Please go. There we go. And then there we go. Throw empty string so we don't get the rest of them. It is technically, if we're doing columns 0 length, yep, they are columns. So we're second 2, 1, 0. Yep, they're columns. And these are the rows. Yeah, okay, I wasn't crazy. Can we map over columns to get new number? We immediately... Maybe. Maybe try to squeeze that one in there. Yeah, okay, it's fine. Fine, it is. I was gonna map over this, over columns to get this, but the map would have to be column sliced -1. Let's see how bad it would look. Map, row, column. And they have to join up, and then you gotta trim. Let's see if that did the trick. You know what? It's not actually that gross. I like it. I like it a lot. No mapping over this, because you'd have to do a full-on reverse on columns. Ooh. We have the technology. How unreadable do we want to go, though? That's a big question. So that is columns. Ooh, that's interesting, because we're not actually using the value. We're using it for its index. Okay, I'm not going to go that far. I'm not going that crazy. Okay, I think that is sufficient. Okay. I think with this, I'm going to call the refactor done. So, way it works, we jump into our generic solver method. Generate numbers and operator. There we go. We pass it the data, and we pass it this helper function we'll talk about later. We first pass it the data to our parse problems. The goal of this is to generate the lines of the problem, like so, with all white space preserved. Very important that happens. So what this does is that goes through every single line, and first it calculates the width of the columns. Oops, on optimization there. There we go. It calculates the width of the columns. It does that using the last line, which is the operator's line. It looks like so. Notice it's got spacing between these, and that tells you how wide the column above is. 3, 2, 5, lots of different widths. So it goes through each of these characters in the operator's line. We have some extra ones to make sure it cleans up after itself. Ignore that. And if it's a space, the width of the current column is increased. But if it's not a space, that means, boom, we reached a new operator. Note that the operators themselves, they're always at the beginning of their column. So we can use that consistency to detect that, and then once we do detect that, we say, congrats, we got you covered. That is your width of that column, and we reset it to 0. We have these extra 2 bits here, so that way the width of the last column is taken into account. We have this slice here because the first one technically starts with an asterisk, and that would throw an extra 0 wide column into the count. So calculate the width of the columns, and then we go through it to build up the actual values of the columns. And we do this by iterating through each of them, keeping track of the columns we've built and the width so far. That's important because as we go through it, we will need to get the formatting just really hates us here. But like if we're here, then we need to be an offset of 4 characters based off of the widths we've already gone so far. So 3 plus 1 for spacing. What you'll see is width so far, the width of the current column, and 1 for spacing. That allows us to target starting at how far we've already been to how far we've already been plus the width of the current one. I made this very ugly and unreadable with reduce, but it's as simple as it was before. Then we access the columns that we care about. We do all that to parse out these here beautiful lines with all white space preserved. Very important. Then what we do is we start going through the lines, column by column, and we pass the current column number and the lines to our cool helper function that generates the numbers and the operator. That differs from part 1 and part 2, so we'll pass that on. We then rip the operator off, so you can see we get column back. This is great, but we just want the operator, and specifically we also want the operator removed from the rest of the symbols here. So we use splice, target the last one, extract it accordingly. Then instead of actually doing math, we just send it to JavaScript's eval. We could have made a math function with a switch case for which operator was going on. Did not care to do that. So we pass it there. We join the column together with the operator, which if I were to show you, looks like this. There you go. Looks like a good old expression. All the white space thankfully doesn't matter. And then we add all those results to our total, and we're done. Now, for part 1, the generation of the numbers and operators was straightforward. It's 1, 2, 3, 45, 6. So it's just the original data there already. So for each line, you have the current line, the row of lines, you just grab that one out. It's a basic loop of, instead of classically left to right, it's top to bottom. Part 2, of course, is where we do a little bit more. So we do the exact same thing. No, I'm not paying for get lens. So we do the exact same thing to get out the column as a row, as a single array. But then we got to go through each of them and extract, in this case, 3, 5, 6, 2, 4, and 1. And I said it backwards, didn't I? No, I said it correct this time. There we go. So we go through this as they were columns, get the 3, get the 5, get the 6. So we're starting at the rightmost column index, which is why it's a negative. It's an inverted for loop. Then we go 2, 4, and then we also get the space, though it doesn't really have an impact. And then we grab the 1. And we grab all these, we put them into our new array like so. Beautiful. And then we return all those numbers with, of course, the operator, which is at the end of the original columns. And the rest of it is handled normally. So yeah, that is this problem. Like I said, a little off kilter, not my normal computer, but got it done. So look forward to the next ones. Bye bye.